In 2023, there were three scientists, Pierre Agostini, Ferenc Krausz, and LHuillier from France, Austria, and Sweden, respectively, who received the prize for experimental methods that generate attosecond pulses of light for the study of electron dynamics and matter. We shall learn about them one by one. But first, let's see what they have achieved. Attosecond physics. It is a rapidly developing field that uses ultra-short pulses of light to study electron dynamics in matter. It are the shortest units of time, and they are 1/billionth of a billionth of a second. Attosecond pulses of light are so short that they can be used to study the motion of electrons in atoms and molecules, which occur on attosecond timescales. There are a number of different experimental methods that can be used to generate these pulses of light. One common method is high-order harmonic generation, HHG. In this, a high-intensity laser pulse is focused on a gas target. The laser pulse interacts with the gas atoms, and it ionizes them. As the ions recombine, they emit high-energy photons, which are known as harmonics of the laser pulse. The harmonics are then separated by their wavelength, and the attosecond pulses of light are obtained. Another method for generating pulses of light is photoionization. In this method, a laser pulse is used to ionize an atom or molecule. The photoelectrons that are emitted from the atom or molecule can be used to generate attosecond pulses of light. Once pulses have been generated, they can be used to study electron dynamics in matter. One way to do this is to use attosecond pump probe spectroscopy. In this technique, a pulse of light is used to excite an atom or molecule, and a second pulse of light is used to probe the excited state after a certain delay. The delay between the two pulses can be varied, which allows scientists to study how the electron dynamics evolve over time. Attosecond physics is a powerful tool for studying electron dynamics in matter. It has the potential to revolutionize our understanding of a wide range of phenomena, including the dynamics of chemical reactions, the behavior of materials under extreme conditions, and the interaction of light with matter. Enough of the architecture, let us learn about the architects. Pierre Agostini. He is a French physicist who was awarded the 2023 Nobel Prize in Physics jointly with Ferenc Krausz and LHuillier for their groundbreaking work in attosecond physics. His work has helped to develop new methods for generating and measuring attosecond pulses of light, which have allowed scientists to study the fastest processes in nature, such as electron dynamics in atoms and molecules. Agostini was born in Paris, France, in 1946. He studied physics at the École Polytechnique and the University of Paris Sud. He received his PhD in physics from the University of Paris Sud in 1975. His doctoral thesis focused on the development of new methods for generating and measuring ultraviolet laser radiation. After receiving his PhD, he joined the research staff at the Centre National de la Recherche Scientifique, CNRS, in Paris. At the CNRS, he continued his work on ultraviolet laser radiation, and he also began to develop new methods for generating and measuring attosecond pulses of light. Agostini's major scientific contributions are in the same field of physics. He has developed new methods for generating and measuring these pulses of light, which have allowed scientists to study the fastest processes in nature, such as electron dynamics in atoms and molecules. His work has also led to the development of new applications, such as ultrafast imaging and spectroscopy. He is a strong advocate for science education and outreach, and has given numerous lectures and talks on attosecond science to students and the general public. He is also a member of the board of directors of the Fondation Pierre-Gilles de Gennes, which supports research in physics and chemistry. His work has led to the development of new methods for generating and measuring pulses of light, and new applications for attosecond pulses of light, such as ultrafast imaging and spectroscopy. Secondly, Ferenc Krausz. He is a Hungarian-Austrian physicist who was awarded the 2023 Nobel Prize in Physics as well. Krausz was born in Miskolc, Hungary in 1962. He studied physics at Eötvös Loránd University in Budapest, where he received his PhD in 1991. After completing his PhD, Krausz moved to the Max Planck Institute for Quantum Optics in Garching, Germany, where he worked as a postdoctoral researcher. His doctoral thesis focused on the development of new methods for generating ultra-short laser pulses. After completing his PhD, He continued to work on this topic, and in 1996 he and his colleagues developed a new type of laser amplifier called the chirped pulse amplifier, CPA. The CPA revolutionized the field of laser physics, and it is now used to generate the most powerful laser pulses in the world. Krausz's major scientific contributions include the development of new methods for generating ultra-short laser pulses, the discovery of attosecond physics, and the development of new techniques for imaging and manipulating electron dynamics in matter. In 1996, he and his colleagues developed the CPA, which allowed them to generate laser pulses with durations of only a few femtoseconds. A femtosecond is 1/4,000,000th of a second. This made it possible to study electron dynamics in matter, which occurs on the attosecond timescale. Krausz's work in this field of physics has led to new insights into the behavior of electrons in atoms, molecules, and solids. He has also developed new techniques for imaging and manipulating electron dynamics in matter. This research has the potential to lead to new advances in electronics, materials, science, and other fields. He is the founding director of the Max Planck Institute for Quantum Optics in Garching, Germany. He is also a professor of physics at the Technical University of Munich. Krausz is a strong advocate for science education and outreach. He has given numerous public lectures and interviews, and he has written several articles on science for a general audience. Ferenc Krausz is one of the leading physicists of his generation. His work on ultra-short laser pulses and attosecond physics has revolutionized the field of physics and led to new insights into the behavior of matter. Krausz's work is also having a significant impact on other fields, such as electronics, materials, science, and medicine. Finally, LHuillier. She is a French physicist who is also best known for her work in the same field. Her work has helped scientists to better understand the dynamics of electrons in matter. She was born in Paris, France in 1959. She studied physics at the École Polytechnique and the École Nationale Supérieure de Physique de Paris. She received her PhD in physics from the University of Paris Sud in 1986. LHuillier's doctoral thesis focused on the development of new techniques for generating high-intensity ultra-short laser pulses. After completing her PhD, she worked as a postdoctoral researcher at the Max Planck Institute for Quantum Optics in Garching, Germany. In 1987, she and her colleagues developed a new technique for generating attosecond pulses of light. This technique is now known as high-order harmonic generation, HHG. It has revolutionized the field, and it has enabled scientists to study the dynamics of electrons in matter with unprecedented resolution. She has also made significant contributions to the development of new laser technologies. She has developed new types of lasers that can generate attosecond pulses of light with high power and efficiency. These lasers have enabled scientists to perform new experiments in attosecond physics, and they have also found applications in other fields, such as medicine and materials science. LHuillier is a strong advocate for science education and outreach. She has given numerous public lectures and interviews about her work, and she has written several popular science articles. She is also a member of the board of directors of the European Physical Society. Anne is one of the leading physicists in the world. Her work on attosecond physics has revolutionized our understanding of the dynamics of electrons in matter. In next episode, we shall cover scientists who won the prize in 2022. Stay tuned.